Hello, this is Ellie from the Math Center, and today we're going to be talking about trig identities, specifically the Pythagorean identity and a proof for hyperbolic trig functions. So first, let's write down the Pythagorean identity. Pythagorean identity. This is sine squared theta plus cosine squared theta equals 1. So there are various other forms of this Pythagorean identity, and a lot of students complain about needing to memorize many different forms of this identity. But there's a very simple way to go between them without any memorization. So in order to rewrite this identity using cosecant and cotangent, you can multiply this entire thing by 1 over sine squared. So if you have 1 over sine squared theta times sine squared theta plus cosine squared theta equals 1, you get sine squared theta over sine squared theta plus cosine squared theta over sine squared theta equals 1 over sine squared theta. Now sine squared theta over sine squared theta is going to equal 1. It's the same thing as writing 1. Plus cosine squared theta over sine squared theta is equal to cotangent theta. Cotangent squared theta. So we have cotangent squared theta. And 1 over sine squared theta is cosecant squared theta. Similarly, you can multiply this entire thing by 1 over cosine squared theta. So we have 1 over cosine squared theta times sine squared theta plus cosine squared theta equals 1. And we would have sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta equals 1 over cosine squared theta. If we simplify this, sine squared theta over cosine squared theta is going to equal tangent squared theta plus cosine squared theta over cosine squared theta is the same as writing 1. This is equal to 1 over cosine squared theta, which is the same thing as writing secant squared theta. So starting from the Pythagorean identity, which we all remember, we can do very simple algebraic manipulations to get other forms of the Pythagorean identity. So this is just something to remember so that you don't have to memorize these other formulas. Now let's talk about hyperbolic trig functions. So hyperbolic trig functions, hyperbolic trig functions. Some examples of this is sinh sine h theta, which is equal to e to the theta minus e to the negative theta over 2. Also there's cosh cosine h, this is the hyperbolic part, theta, which is equal to e to the theta plus e to the negative theta over 2. And you can see this, the difference here is that the sine has a minus, and the sinh has a minus, and the cosh has a plus. So something that an example of a problem that one might have to solve using hyperbolic trig functions is this. Prove that tanh squared of x is equal to 1 minus sech squared x. So we look at this and we say, hang on, what's this tanh? What's this sech? So let's figure out what tanh is first. Tanh of x is equal to sinh x over cosh x, which is equal to, if we replace it here, e to the x minus e to the negative x over 2 over e to the x plus e to the negative x over 2. So these 2's will cancel out, and we get e to the x minus e to the negative x over e to the x plus e to the negative x. And then sech of x is going to equal the reciprocal of cosh. So we will get 2 over e to the x plus e to the negative x. So now, starting from here, from these, now that we know what tanh and sech are, we can start with the left-hand side of this equation and work our way to make the right-hand side of the equation, and that will allow us to prove this identity. Okay, so here we go. We start with tanh squared of x, which is equal to e to the x minus e to the negative x over e to the x plus e to the negative x, quantity squared. This is going to be equal to e to the x times e to the x, right? We have to FOIL the top, so the first, and then we do the outer, which is going to be this one and this one. So we do minus e to the negative x times e to the x minus, we do the inner, which is going to be this one and this one again, e to the negative x, e to the x, plus the last. So it's negative e to the negative x times negative e to the negative x, or plus e to the negative x times e to the negative x. Now we also have to FOIL the denominator. So our denominator is going to look very similar. But we have e to the x times e to the x, which is the first. Now we do the outer, so we're going to have plus e to the negative x, e to the x. Now we're doing the inner, which is going to be plus e to the negative x, e to the x, and then the last, plus e to the negative x, e to the negative x. So let's combine some terms, do these multiplications. So we get e to the 2x minus e to the 0, because this negative x plus the x is 0, minus e to the 0, 0, plus e to the negative 2x. And in the denominator, we have e to the 2x, combining these two, plus e to the 0, combining these two exponents, plus e to the 0, combining these two exponents, plus e to the negative 2x. So if we evaluate the e to the zeros as 1s, so we say each one of these is a 1, we can add them up and we get e to the 2x minus 2 plus e to the negative 2x over e to the 2x plus 2 plus e to the negative 2x. So what we're trying to do is trying to get two terms. One of the terms we want to be equal to 1, and the other term we want it to equal secant squared x. So we have to do something to the numerator to break this up. So one thing we can do is rewrite it, but pretty much add and subtract a term. So it's pretty much like adding 0. So you get e to 2x minus 2 plus e to negative 2x. And now all I'm going to do is I'm going to then add 2 and subtract 2. So over here, it's like adding 0. It's like we did nothing. And in the denominator, we have e to 2x plus 2 plus e to negative 2x. So if we break this up into two terms, we get e to the 2x plus 2 plus e to the negative 2x over e to the 2x plus 2 plus e to the negative 2x minus, and we have the quantity where if we add up these two terms, or these twos together, we have minus 4 over e to the 2x plus 2 plus e to the negative 2x. This first part over here equals 1. This part over here is equal to secant squared x. There you have it. We have proved that tanh squared of x is equal to 1 minus sech squared x. I hope this helps, and we'll see you at the Math Center.